circuit rider, and our circuit rider is the intern position that visits numerous companies, works on small projects during the summer with each one of those companies. Eli is a senior here at Kansas State University, and his major is biological systems engineering. And as you can see, he has a quote here about his time with PPI as an intern. So, Eli, I'll let you take it away.
First thing I'm going to see is if everyone can hear me, both online and offline. Just make sure. And since everyone's like 20 feet away from each other, hopefully, if everyone's okay with it, I'm going to take off my mask so everyone can hear me and see my lips clearly. Is everyone ready? Cool. Hello, everyone. My name is Eli Miller, and as Linnell Ladd said previously, I'm a senior at Kansas State University in Biological Systems Engineering. And today I will be presenting my results of my internship this summer working with the Pollution Prevention Institute at Kansas State University. This year, I had the privilege to work with 6 different companies this past summer. In order to hold their confidentiality, I will just boil them down to essentially what their industry is. I worked with a food processor, a steel fabricator, a steel parts manufacturer, a vehicle manufacturer, health and safety operator, and a food processor. For each of these companies, I will cover the site visit when I initially went there, the initial things I found that they could have corrected. I will cover my research and calculations I did on the company, and then finally present my final solutions I made to that company in their report. So the first company I will cover is a food processor. This is my first site visit I went to, and the initial things I found at this company will be a running theme throughout the entire rest of the summer and the site visitations I went to. The initial things I found at the facility is they had several different types of fluorescent lights at the facility, which are not necessarily as efficient as they could be. In addition to these fluorescent lights, they also used a compressed air system, which basically ran 24/7, constantly processing compressed air. And finally, the last thing they did is at the facility, they specifically asked me to do solar panel calculations at the facility because they were looking to reduce their energy use, especially since they are going to add and build their industry even further. So they're looking to reduce the demand on the electricity. The research and calculations I did for this facility, the first thing I did is examine the lights. I actually had to do 2 site visits at this particular location to get specific data on these lights. The reason for this was because this facility did not buy their lights en masse. Anytime a light went out, they went to a store, bought lights that fit, and they came back. So as a result, it was not all lights matched, either in illuminance, wattage, or elsewise. So I had to go to a second site visit with an illuminator and also take close pictures of each of the lights in order to get correct research. I also used a UE 9000 system for leaks. This device was incredibly useful to detect compressed air leaks throughout their system, which helped them fix those leaks and save money and electricity in doing so. I also found estimates for solar panels. I did this by going to a solar panel estimator online, specifically because solar panels vary so wildly in cost based on the manufacturer and who installs it. So what I did is I used an estimator in order to get a range of values that the company could use. And finally, I calculated the dollar per kilowatt hour for this company by utilizing their previous bills to figure out how much money it costs per kilowatt hour used. So after doing the research and calculations, these are the solutions I present. The first thing is switching out their fluorescent lights with LED lights. Second thing is to fix the leaks that I found using the UE 9000 system. And the third thing was I presented to the company a solar panel estimate as they requested. The results of this was the LEDs and the fixed leaks were things I recommended, whereas the solar panel estimate I didn't recommend for them to implement, simply because in order to meet the energy demand they were outputting, it would have to cost them a ridiculous amounts of money unless they installed it themselves. And as Linnell and I saw through working, they didn't have the amount of workers capable, they didn't have the amount of workers to install such a large frame of solar panels. And if they had to hire outside help, it would cost an exorbitant amount of money. Second thing I covered is a steel fabricator. Now, the first thing I did is, with this place, it was very similar to the others. They had fluorescent lights and then compressed air system. So they had the same situation as the company before. The research and calculations for this facility were similar, but there are a couple other things I added. This facility, I also had to go to a second site visit for because I needed to test the luminance of the site. When we first visited, the facility seemed a little dark for their working conditions. Especially at a steel fabricator, safety is incredibly important with them doing very detailed work at high temperatures, and it could be a safety issue if they didn't have enough light. So what I had to do for my second visit is bring in a tool that would measure the illuminance. And from that, the replacement lights that I suggested would meet that demand that they needed in order to work safely in their work environment, as well as save them energy. I also used the UE 9000 system for leaks. This facility in particular used a lot of compressed air for tools, cleaning, and et cetera. So the UE 9000 system was incredibly helpful, especially with the loud work environment. And the third thing I did was calculate $ per kilowatt hour, again, using the bills they provided me. For these solutions, it was very similar to the last company where I just suggested new LED lights. These lights were particularly, I researched and found the lights that they needed in order to meet the illuminance demand that they needed. And then also I sent them a report detailing the air leaks, how much they cost, and how they would fix it. As you can see in the picture to the right, this is how I calculated air compressor hours in order to find the total costs. Most companies will provide an air compressor maintenance list on the compressor themselves. And this is actually incredibly helpful for detailing how much a compressor runs in its lifetime. So as you can see, they have the date and the total hours running. And through that, I used those numbers to calculate how much hours it ran an entire year. That was incredibly helpful. For this company, I worked for a steel parts manufacturer, and the problems were, they had the similar problems in the past as well as a couple others. As in the past, they had fluorescent lights. Now these lights were constantly switching over to LEDs, but they still had some fluorescence that they hadn't made the switch over to yet. Second thing is they also use compressed air system as well as welding gas. Now, the compressed welding gas system also had leaks in it, and they used a combination of CO2 and argon for their welding gas. And then the final thing was their solvent storing and use. They're using quite a bit of solvent, and they weren't reusing it. They were simply using it and dumping it, and so that was also a potential thing I saw that could save them. So for my research and calculations, I did kilowatt hour savings for replacement bulbs and the compressed air, as I did in the past. Used the UE 9000 system for leaks, and I also researched a proper reclamation unit for their solvent. In addition to this research, I also did research on other projects that I didn't recommend, such as paint and their paint sprayers. For the solutions, I presented with new LEDs. I told them to fix the leaks both on the compressed air and the welding gas system. And then I also presented them with a reclamation unit. For the reclamation unit, I researched by talking to several different companies about what would be the proper system for them to use based on how much of solvent they used and what type of solvent they used. And then I presented them with the fact sheets and the spec sheets of the design, as well as where they could purchase it and how much it would save them per year. Next company I worked with was a vehicle manufacturer. Now, this company was very clear on what they wanted from the start, is that they really only wanted us to work on compressed gas or compressed air. And so that's why I worked with. So the problem was the compressed air system. My research and calculations included the UE 9000 system for leaks and the calculating dollar per kilowatt hour. As you can see to the right, this is what the UE 9000 system does, is it measures compressed air leaks through sound, basically, and it bounces off, and you can hear, using headphones, the leaks, even if it's really loud in the facility. And to the picture to the right, you can see basically where the location of the leak is, as well as that cost per year based on the kilowatt hour. And as you can see, most leaks, I would say about 99% of leaks I found were at joint areas of connections, and they were either loose or not properly fastened, or it was damaged in some way. And that, you know, as you can see, it's $180 for one of those leaks per year, just simply because the connection isn't all the way tight. And then, so again, the solution I presented was fixed leaks. Next person I worked with was the health and safety operator. The problems at this particular area included is an updated inventory. This company basically did chemical inventory for a large system, and so they wanted my help in adjusting their methods for handling the chemical inventory and how they outreached to the PIs of the facilities. So the problems were an updated inventory. And this goes along with the other problems as well. They didn't have regular reports, and the communication between them and the PIs was small, and they had an old system. And all these problems led to one big problem, in which their inventory throughout the past decade had been severely unupdated. And you know, the problems included they didn't have the people to work for to regularly update their inventory. People weren't sending their reports for what inventory they had. They wouldn't adjust their inventory. The communication between them was very small, so they didn't have regular meetings. They didn't meet with their PIs. A lot of the PIs didn't know what to do. They wanted to include their inventory, or they had been personally, but hadn't been reporting it. So that communication between the two was very small. And finally, the company was using an old system from about 2012 that wasn't online, so they had to manually enter every chemical adjustment per, you know, PI. And so that took an enormous amount of time, and like I said before, they didn't have the people to do that. So there is a big backlog of problems as well. So the research and calculations I did for this company is, the first thing I did is I developed educational communications that the company could use to outreach to their PIs in order to educate them and encourage them to report their chemical inventories to the company so they could update it. Second thing I did is I performed an audit on one of the PI's areas. And so what I did is I contacted the PIs and communicated with them and said, hey, can you please give me your chemical inventory? And then I basically talked with them through the process in order to figure out what their chemical inventory was. The third thing I did was I viewed a lab. The picture to the right shows my results of that. So what I did is I went to a particular laboratory and I looked at the chemicals they had in the lab, and I compared that to what their reported chemical inventory was. As you can see here, this list is a reported chemical inventory that they reported earlier in the year, and the dashed lines on top were the amount of chemicals that they had that did not match what they reported. And it added up to something around 56 chemicals that they had in their lab that they did not report. And this was a lab that had updated their inventory and submitted it earlier that year. So there were some labs that hadn't updated it or sent in their inventory in something 3 years, 5 years, sometimes even 10 years. And so this is an example of where if you don't regularly update your inventory, you can get an enormous amount of problems about you don't know where chemicals are going. And so, you know, this was an example of showing they just really needed to update it either bi-weekly or once a week in order to maintain good communications and knowledge of what chemicals they had. Um, and the final research and calculations I did was I looked at available technology that other companies have been using to use their chemical inventory and suggesting that they would purchase that equipment in order to make it easier for them. Because there are currently tools online that you can use to keep an online inventory that the company that you hire for would manage it. And so it would take, you know, that time out of their hands. And it would, in the long term, save them money because they didn't have to keep throwing away unused chemicals or wasted chemicals that would otherwise be saved. So the solutions I did for the company was I said update the current system. They really needed to, you know, hire outside help in order to get online systems. And the second thing was improve communications and with the safety coordinators. So they needed to talk with the PIs of the labs. They needed to talk to the safety coordinators in order to establish that communication so you can start getting updated inventories more often. The next company I worked with was a food and beverage manufacturer. The problems here is the first thing I noticed was water leaks. As you can see to the right, there's a picture. And this is just one of the leaks that I found at the facility. There were water leaks, there were significant water leaks throughout the facility. This is just one example in which they, you know, had a leak and they did a quick fix to it. But in the long term, it didn't really fully, you know, solve the problem. And what I investigated further is I found that this was really because the amount of people they had working to maintain the facility. They were constantly, you know, working in order to maintain other significant aspects of the facility. And so when you came across a water leak like this, it wasn't as seen as a significant problem. So next thing I worked with was sanitation. Now with the sanitation at the facility, they used 3 different methods of sanitation at the facility in order to protect from COVID and protect their industry of food and beverages. They used 3 different methods for feet of the facility. So what you would do in the facility is you would first walk in, use a type of boot sprayer in which you would press your foot down on an item and it would spray your boot with alcohol in order to clean it. And then you would go through a different door and they used a different method in which they basically sprayed cleaner and a water mixture on the floor and it just kind of formed a puddle and then every 8 minutes it would reflush the system and you would walk through that in order to clean your foot again. And then if you walk through a different door and some of the entrances of the facility, they also had powder in which you would put your feet on in order to clean it as well. So they had all these different methods. And so I found that a lot of times it overlapped unnecessarily. And so they were potentially using a lot more chemical than they needed to. The next problem I found was they used air vibrators in order to dislodge material from some of the pipes they used. So a lot of these air vibrators, what they do is you throw compressed air into the system, and then that's how it uses it to vibrate. The only problem with this is that the old vibrators that they're using were called ball vibrators, and they not only absorbed a huge amount of air, they also were incredibly loud. And so the amount of energy that went into just one of them was extremely high. And then the final thing I looked into was, again, a compressed air system throughout the facility. The research and calculations I did for this facility is the first thing I did was timed and measured water. So what I did for this is I basically held a measured cup for a minute of time, which I recorded and filled up the cup and measured how much volume of water it was in that time. And through that, I got a flow rate, which I applied throughout the entire year and got an approximate amount of volume that they lost per year for that leak. I did this for a couple leaks, but I didn't do it through the entire facility because some of the leaks were obvious that they were leaks, such as this, but then other times it was not so clear about where the source of that water was. And upon talking to some of the maintenance crews, it would either came from steam loss or some other sources. So it was really hard to say what was a leak and what was not a leak. Some were obvious like this, but others were not so clear. The second thing I did was calculate the amount of sanitation used at the facility and see if there was any possible way to decrease the amount of chemical they used, but still not risk the sanitation of the facility. So what I did is I found out what type of overlap happened, and I figured out that the boot sprayers that used alcohol and that the the chemical mixture they used that formed a puddle on the ground basically did the same thing, accomplished the same task that they wanted to. So I discussed with the main safety coordinator at the facility, and we discussed methods for what we could do if we're placing one or the other. And so I calculated the amount of sanitation that could be reduced either way and what would be the best method of going forward. I also looked into alternative vibrators that they could use. So at the facility, I talked to a couple of maintenance crews about it, and they knew the problem as well. And so one of the guys recommended and handed to me something, the equipment they were thinking of replacing it with. And what I did is I took that and basically calculated the savings they would do by replacing that equipment with what they were suggesting. And I also researched further into other methods they could use, but I actually found that the equipment they were going to replace it with was the best option. So that was pretty good to see. And the last thing I did was use the UE 9000 system for leaks as well. So the solution I found was, the first thing was, of course, fix the leaks of the water and the air. Of course, when they have the opportunity to, it can save them lots of water and electricity costs. The second solution was switching to the alcoholic boot sprayers. This would save them from constantly dumping chemical on the floor that could cause potential problems. And the third one was replacing the Balls air sprayers, their vibrators that they were currently using, and replacing them with pneumatic air sprayers, which use significantly less amount of air and was a lot more quiet. Now, the solution I presented about switching to the alcoholic boot sprayers is, it was a solution I presented, but it was something that I left up to the company to decide. Mainly because while they were going to get rid of the chemical that was being sprayed onto the floor, I did find that it would increase the amount of alcohol they would have to use for the boot sprayers. So while they were reducing in one chemical, they were increasing in another. And so alcohol would increase their amount of air emissions. And so it was kind of a trade-off in what they were actually going to achieve. So I left that up to the company in order to say, hey, this is up to you. Now, this solution did help them save quite a bit of money, but since our main goal here is to help the environment, I didn't want to recommend something that had potential trade-offs just for a buck. So with my conclusion, I went to 6 different companies, and the potential results that could be netted from switching over to the solutions I presented. The estimated savings are 1,275, 316 kilowatt hours, 2,826 gallons of water, 18,436 pounds of virgin lab cleanout from chemical and hazardous waste, 248 gallons of N-butyl acetate, which is a VOC, 1,335 metric tons of CO2, and $130,148. These were all the potential estimated results. And I'm very excited I could help all these different companies throughout my journey here. And I learned a huge amount from this experience. I hope you all enjoyed my presentation, and I believe it's time on for questions.